Good afternoon, students. How are you all doing? Just let me know if my voice is clear, the video is fine, so we can start. Okay, perfect. So yes, we are going to start combinatorics. It's going to be the next couple of weeks. We are going to be studying combinatorics. It's entirely in English. This course is especially for those students who are not that comfortable with Hindi. We have brought this course for you. I know it's very hard to understand something in another language, so we really cared about you. We really listened to your request, and this course is going to be entirely in English, which means the entire country should be somewhat listening to this, somewhat be able to understand this, right? Because a lot of you, I know you are comfortable with English, you're comfortable with the Olympiad in English, but if you're not, there's already courses in Hindi, in English, whichever language you prefer, but just for your information, this course is going to be entirely in English. Okay? Okay. So the topic combinatorics, it is one of my favorite topics, not because it has a lot of interesting theory. It's more about how you apply that theory. So it's very easy. Understanding the theory part is the easiest in this chapter, but how do you apply that knowledge? How do you actually solve problems? That is the trickiest part. So we are going to start from absolute zero level. We are going to start from very basic level, and we're going to move on to advanced level. Some of the topics I learned at IIT. So yes, this course is going to take you from zero to literally an advanced course. So I hope you guys are excited. Okay, there seems to be some voice issues. Usually there isn't. Just let me know if the voice is an issue. I will check. Okay. It seems normal from my end. Let me still confirm. Okay, so it seems everything is as high as possible from my end. If there is any issue, maybe check your system. Maybe the volume of your device is not the highest it can be. I hope you can figure it out. You guys are smart. You guys are very tech savvy. I know you will be able to handle it. All right. So I see some questions in the chat. Have I given RMO? Yes, I did. I did not have IOQM back in my days. Like I graduated from high school in 2014. That's when I appeared for JEE. So back then we did not have IOQM. I'm so happy that you have an easier level to get you started. You don't directly have to go to RMO now. But yes, I did appear for RMO from Delhi, and I was in the list, but I did not go further because I knew I really wanted to go for engineering. I wanted to focus on JEE, and that's what I was told, that I should focus on JEE. I don't know if it was the best decision. Maybe I would have enjoyed the other path as well, because I do love maths. If you know me, you know I love maths, and I would have loved taking that path as well, but it was just not part of my plan, so I just stopped. I took the test and I was in the top 20 list. Those were the ones who could, I think, qualify for INMO or something like that, but I did not go further. I did not go for the camps or anything. So yes, I did not really prepare, unlike you all. I did not prepare for RMO, I just did it for fun. I did just go through the questions from time to time over the years, because they are very interesting problems. It really is a very good exercise for your brain. So I have been going through RMOs, INMOs over the years. They are some amazing problems. So I'm very happy for you that you are preparing for it. It is going to be really effective no matter what path you are going to take in your life. Trust me. If you are learning maths that way, if you are actually exercising your brain that way, you're going to prepare for every field, because you're actually preparing to learn better, to be able to apply those things better, and that is going to be helpful no matter where you go in life. Okay, a lot of long messages. What's the correct approach to do the questions? You understand the theory, you understand the solved examples. Okay, that is a very common problem, trust me. That's the most common problem in your prep days, right? That you are able to understand the theory, and once you see the solution, you're able to solve the questions, but it's somewhat impossible to approach a new problem, a problem that you've never seen, a difficult problem that you have never seen before. And for that, there is only one solution: practice. The more you practice, the more variety of questions you practice, the more you're going to learn, the more you're going to understand how to see, oh, this seems to be a problem of that topic, even though it's asking for something else entirely, but I have seen something like this before. I have seen how I can solve this kind of problem by using that particular approach, because I practiced. So trust me, there is no one-shot trick. There is no, if someone claims that, you know, this is the way to actually be able to solve any question, no, there is not. It's only by practice. It's only by being mindful while practicing. I'm going to talk more about that from time to time, but let's start. I don't know. I think everything is fine. I use this setting for all my videos. It's really low. So combinatorics is a topic that is somewhat common in JEE as well as IOQM. So you are preparing for JEE as well. In fact, you're preparing one level up. So you're not just preparing to the JEE level, but you're actually preparing to a level above that. So yes, it's going to be very similar. Yes. So in JEE we call it permutations and combinations. Here, because it has some topics other than PNC as well, so we call this combinatorics. This entire field is called combinatorics. Okay, so let's start. Okay, so some students are saying that the sound is fine. Some students are having a problem. Maybe it's device dependent, which device you're using to watch this video, but I'm sure if you use some earphones or headphones, you can solve that problem. All right, so let's start. See, combinatorics is something very basic. It's literally, especially when it comes to PNC, it's literally answering this very simple question: how many? How many ways can we do this? How many cases are possible? How many options do we have? How many ways of looking at something? That is all what PNC is about. So for example, if we, let's say, ask something very simple: how many 3-digit numbers can be formed using 1, 2 and 3 without repetition? So without any other knowledge of PNC, we can just think we need 1, 2 and 3. We have 3 digits, we cannot repeat it, and we need to form 3-digit numbers. So we have to use all 3 of them. Now the order can vary. It can either start from 1 and then second digit can be 2, or it can be 3 and the remaining digit is 2. Similarly, if we start the number with a 2, then we have 1 and 3 left. The second digit can be 1 or 3 and the remaining third digit. Similarly, if we start with a 3, then we have 1 and 2 remaining. So 1, 2 or counted all the possible numbers, right? There's only either 1 will be in the hundreds place or 2 or 3. So we are sure that we have counted all the possible numbers. So that means the answer is, how many are possible? 1, 2, 3, 4, 5, 6. Right? Now, this was easy to count. Let's say, now we have a similar problem, but we added another digit. Now we have to form 4-digit numbers using 1, 2, 3 and 4. Let's count. Now, same as before. The thousands digit, the first digit from the left can be 1, 2, 3 or 4. Right? Then next digit can be 2 or 3 or 4. It cannot be 1 because no repetition allowed. So let's count like this. Then further we are left with 3 and 4. So the next digit can either be 3 or it can be 4. Now the fourth digit we know because only one digit is remaining. In this case it's 4. In this case it's 3. So like this we can count for each of these cases. Let's do it quickly. 1, 3, now 2 and 4. So 1, 3, 2, 4, 1, 3, 4, 2. 1, 4, so what are the two digits remaining? 2 and 3. So 1, 4, 2, 3, 1, 4, 3, 2. So starting now, just observe a pattern. If we started with one particular digit, we could form 6 numbers. So if we start with 2, we're going to get another 6 numbers. We're going to start with 3, then we get another 6 and another 6. So total 6 plus 6 plus 6 plus 6, 24. If you don't believe me, you don't want to take any risk, let's count them all. 2, 1, 3, 4, 2, 1, 4, 3. Then 2, 3, 1, 4, 2, 3, 4, 1. 2, 4, 1, 3, 2, 4, 3, 1. And so on. Do you really want me to finish all of this? Okay, I know you guys know the answer. You guys know how to calculate. This is very easy, right? But we are going to start from basics. We are going to understand where those formulas are coming from. So as we thought, 6 numbers with each starting digit, right? So total answer is of course 24. But a thing to observe here is, once we fixed the thousands digit, now we have 3 remaining digits, right? We have, let's say we fixed the first digit as 4. Then we had 1, 2 and 3 remaining, and then essentially we had to form 3-digit numbers after 4. And we saw that 3-digit numbers using 1, 2 and 3 is 6. So that is why, starting with 4, we got the exact same 6 numbers. 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. So that is why once we fix one digit, we are getting 6 numbers. And for that one digit, that thousands digit, we have 4 options. 4, 3, 2, 1. For each of these cases, we are going to form 6 numbers just like before. So that is why we get 6 plus 6 plus 6 plus 6. But we saw that to be 100% certain, we cannot keep writing all the numbers, right? I mean, this was just 4 digits. What if we want to check for 7 digits? What if there could be repetition? We can't list all the cases. We need to be smart about it. We need to see these patterns and find some sort of a formula to do it much faster, right? So that is where the addition and multiplication principle comes in. Let's see what it is through an example. But in general, for combinatorics, for PNC problems, the theory is best understood through problems. If I just tell you the theory, you might believe me, but it will be harder for you to understand where it's coming from, why it is the way it is, unless we see an example. Okay, so we are going to learn this entire theory through examples. So let's take a look at this problem. A person can travel from city A to city B either via road, by car, by bus, by bike. Three options for the road transport, or by train, either the express train or the mail train. So two options for the train route, and similarly through the flight route, economy or business, two options. So how many ways can a person go from city A to city B? Either he will take the road route, for that he has three options, or he will take the train route, for that he has two options, or he will take the flight route, for that he has again two options. So total possible options is 3, or these two, or these two. So total is 3 plus 2 plus 2, 7, right? Very simple. Out of these 7 options, he can take any one. So he has 7 ways of going from city A to city B. So that means if we ever have an OR situation, we are simply adding. So this is one thing you have to remember, that whenever it's an OR option, like either one case is possible or another, one option is possible or another, in that situation you always add. Either he can take the road route or the train route or the flight route. Alright, so that is when we add. But what if it's not an OR situation all the time, right? For example, now a person can travel from city A to city B via road, train, flight, the same as before. But now city B to city C has other options. City B to city C, so A to B we had 7 options, right? Let's see B to C. B to C we have again 3 road options and 3 train options. No flight options from B to C. So B to C we have either road, 3 options, or train, again 3 options. He will only take one of them. He cannot take both. He cannot take B to C car as well as a train. He will have to pick one. So it's again an OR situation, which means we are going to add them. So 6 options for B to C. Now, in how many ways can a person go from city A to city C via city B? That means this person has to go to B and then C. So we had from A to B, we had 7 options. From B to C, we had 6 options. Now it's not an OR situation. He has to go from A to B and he has to go from B to C. It's not an OR situation. He doesn't have to pick between the two. He has to go to both. He has to go from A to B and from B to C. So in case of A to B, we had 7 options, and then again for each of these options he has 6. Let's say he takes the car route from A to B, then again he has 6 options. Then bus route, if he had taken the bus route, he would again have the 6 options. So in total we would have 7 multiplied by 6. So whenever we have an AND situation, we multiply. Because he has to pick one from these 7 options and he has to pick one from these 6 options. So total 7 multiplied by 6, he has 42 options to go through to go from A to B via C. Yes. You know why 42. So the answer is 42 ways. Now, we understand if there is an OR situation, we add. If there is an AND situation, we multiply. As simple as that. We just have to be very careful. See, but combinatorics is the trickiest in its language. Once you understand the problem, once you understand the entire question, what is the situation, what do we have to do, what do we have to calculate, once you understand that, then it becomes much easier. But first, the first step is to understand the question. Once you understand if it's an OR thing or an AND thing, then it becomes very easy. Now let's take a look at another problem. We have this stadium which has 5 gates. You can enter and exit from each of these gates, any of these gates. Now there are 2 gates A and B on side 1, 3 gates on side 2. Now we have to calculate how many ways of entering and exiting are there. If, let's look at the first question, first part of the question, if it can enter and exit from any door. So for entering, it has 1, 2, 3, 4, 5 options, and for exit, he has again 5 options, and because it's an AND situation, he has to pick an entry gate and he has to pick an exit gate. It will be multiplied, which means the answer is 25 ways of entering and exiting. Any person can choose out of these 25 ways which door they are going to. Let's say they enter from B and exit from D, or they enter from B and exit from B. So in total 5 ways of entering, 5 ways of exiting, so total 25 ways. Let's look at the next part. They can enter and exit from different doors. They have to pick 2 different doors for entering and exiting. If they entered from B, they cannot exit from B, but they can exit from any of the other 4. Similarly, if they pick C for entering, then they can exit from A, B, D or E, but not by C. So that means we have 5 ways of entering. We can choose any of these 5, but once we have picked, then we only have 4. Right? No matter what you choose, for every case, let's say we choose A, then we have 4 options for exiting. If we choose B, we again have 4 options. If we choose C, we again have 4 options. If we choose D, so for each of these 5 cases, we have 4 options for exiting. So that is why we are multiplying. So 5 multiplied by 4, 20. Now let's do the next one much faster than this. We can enter from side 1 but exit from side 2. So for entering, we have 2 options because side 1, and for exit we have 3 options. So total 6 ways. We can enter and exit from any side, but they have to be different, right? Now let's take a look at this. Either we have case 1 that enter from entry from side 1 and exit from side 2, or the opposite, entry from side 2, but then we'll have to exit from side 1. Right? Now, either this will be the case or this will be the case. So it's an OR situation between case 1 and case 2 and an AND situation between these. So for case 1, Case 1, we have 2 options for entry and 3 options from side 2 for exit. Similarly, in case 2, we have 3 options for entry and 2 options for exit. So 6 and 6, but it's an OR situation, so we are going to add, which means 6 plus 6, 12. Very good. So that is how we can just form the question. So in the last case, if we had not been given these first 3 parts, we just have to solve the last question. In that case, we are going to understand how do we enter and exit. It has to be from different sides. So just list all the options, right? Now, let's take a look at another example. Cities A, B and C and D are connected through these routes. These numbers indicate how many ways A and B are connected, how many ways A and D are connected. So that means there are 2 ways of getting from city A to city B, 3 ways of getting directly from city B to city D, B to C2 and so on, C to D 4, right? Now we have to go from A to D. We can either go directly or through B or through B and C, right? So we have to calculate how many ways can a person go from city A to city D without visiting a city more than once. So if we've been to B, then we are not going to go back to B. We are directly either going to go to D or to C and then to D. So we want to go from A to D. So I want all of you to calculate and tell me the answer. Just try carefully, making sure you're not missing any case. Just calmly, patiently, make sure you're counting every single case, every single option, and then tell me the answer. So yes, 24 is correct. Let's see how. So in general, bache, if you're trying to count, there are so many ways of counting, right? You can go randomly. Yeah, it can go from A to D or ABCD or ABD. We are trying to count, but then it's hard to make sure that we did not miss anything. So that is my personal tip to all of you. How do we make sure that we are counting all the cases and not missing anything? You follow an order. For example, when we were counting all the numbers, we followed an order that we first put 1 as the hundreds digit and then check the next 2 digits. And even in that case, I first put 2 and then 3. If I were randomly writing 312, what else? 132 and 123, then it's hard to make sure that you did not miss anything. But if you follow an order, first fix the hundredth digit and then you check the next digits and you do it in an ascending or a descending order, then you have the guarantee that you did not miss any case. Similarly, when I counted these entire 24 numbers, I was following the same order. I first fixed the thousands digit, then even in the other 3 digits, I followed this order: 2, then 3, then 4, and then 3, 4, 4, 3, 2, 4, 4, 2, and so on. Okay, so even in this case, how can we order? How can we fix the order to make sure that we're not missing anything? We will do that by number of cities between A and D. So we have to start from A. we have to finish our D. That is given. But how many cities can be there between A and D? First, we start with 0, which means directly A to D without any other city. Or first list all the cases, okay? Don't start counting right away. First, make sure you've written down all the cases, then count how many ways per case. Or there can be one city between them. Which city? It cannot be C, because there is no way of going directly from A to C, right? So it will be A to B, then to D. Then it can be to A to B to C to D, right? There is no other option, because from A you can either go to D, in that case we have reached our destination, or it can go from B. From B it can either go directly to D, which we have covered, and to C. So these are the only possible cases. Now we are sure, we are confident, because we followed an order. But these might look easy, and they are easy questions, but as the questions get harder, it is very likely that you miss some case. And that is what I always tell my students: follow an order. In that case, there is a complete guarantee that you're not going to miss any case. You're going to count all of them perfectly. Once we have this, then it's an easy question, right? From A to D, there are 2 ways. From A to B to D, first it has to go from A to B 2 ways, B to D 3 ways. So total 6. A to B 2 ways, B to C again 2 ways, and then C to D 4 ways. So total 16. And because it can either choose A to D, or A to B to D, or A to B to C to D. It's not an AND situation, it is an OR situation, which means we add all of these. 2 plus 6 plus 16, 24. So that is how you calculate this entire thing, all the possible cases, by not missing any of them. Okay, there is a doubt, why not take 3? Are you talking about this, bache? Number of cities between A and D? Because total we have 4 cities. Let's say we wanted 3 cities between A and D, but there are not enough, because we can only visit a city exactly once, right? So that is why you have to, of course, very good question, why did we stop at 2? We should check for 3. Is it even possible to have 3 cities between A and D? No, it's not, right? We can maximum have 2 cities between A and D. And this is why these are all the possible cases. We did not miss any of them. Now, once we understand this addition and multiplication thing, that if it's an OR situation, add, AND situation, multiply. Now let's see our previous kind of problem, right? How many numbers can be formed using the given digits if repetition is allowed or not allowed. So in that case, what we are going to do for this kind of questions, we need to form 4-digit numbers, which means a number has 4 digits, the thousands place, hundreds place, tens place, and ones place. We have to fill all these 4 places using 1, 2, 3, 4, 5 these digits. So we have 5 options for each of these, but the first case is without repetition. Repetition is not allowed. If we've already used 1, then we cannot use 1 again. So for this place we have 5 options, right? We haven't filled any digit. We can fill any of these 5. But once we have filled this place, then we only have 4 options for this place. And then once we have, let's say 2 and 5, I have picked 2 and 5, then the remaining 3 digits, any of those 3 digits can come here. So 3 here and then 2 here. And 1 will have to be missing from this number, right? Because we have to pick only 4 digits out of these 5. It is without repetition. So total will be, we have to fill this and this and this and this. So multiply. This becomes 5 into 4 into 3 into 2, 120. Now let's see if repetition is allowed. Again, we have the same 4 places to fill, but now we have 5 options for this, just like before. But now we can fill any of those 5 again, because repetition is allowed. Even if I have filled, let's say 2 here, I can fill 2 again because repetition is allowed. So again 5 options for this, again 5 options and 5 options. So we are again going to multiply because we have to fill all of these, this and this and this and this. So 5 raised to power 4, 625 ways of forming a number. So this is how you calculate how many numbers we can form using digits, by filling the number of digits, those many places with the digits given. Good. Now let's see. It's a similar problem, except now we have a 0. If we form a 4-digit number, something like 0143, then it is not exactly a 4-digit number, right? This is a 3-digit number, which means if it has to be a 4-digit number, 0 cannot be in the thousands place. So now if repetition is not allowed, we have only 4 options for this. But once we have filled this place, let's say we use 2 for this or any of the other. Now we again have 4 options. 2 is not there, but 0 can be there now. 0 can be there, 1 can be there, 3 can be there and 4 can be there. So 4 options for this. And we have taken 1, so now we cannot use it in the other 2, which means this has only 3 options and this will have 2 options just like before. But when it comes to 0, we just have to remember that 0 cannot be in the leftmost position, otherwise it's fine. Once we have filled this with a non-zero digit, then it's the same as before. So this becomes 4 into 4 into 3 into 2, which is 96. Similarly, when repetition is allowed, for first place again we only have 4 options, 0 cannot be there no matter what, and for the other places we have all 5 options, because repetition is also allowed, 0 is also allowed. So for these 3 positions, any of these 5 digits can be used. Only for the first, the leftmost position, we can only choose out of the 4 non-zero digits. So this becomes 4 into 125, that is 500. Okay, so this is how you can fill this just logically. Do not try to memorize any of this, just understand. Yes, 4 options are possible for this, and then we have to pick 1 out of the 5, so it's an AND situation, so we are going to multiply. It's all very logical. Do not try to memorize any of these, that if we are given 5 digits, then it will be something like 96. Chaliye. Now, how many ways can a student answer a multiple correct question with 4 options? We have one question which has 4 options A, B, C and D. It's a multiple correct question, which means you can choose more than one, but you have to answer. So you have to pick at least one, right? So it can be either only A or it can be B and C. So a lot of options. We cannot list all of them, right? That will be very long. So how do we calculate? Give it a minute, give it a thought, and then, okay, someone already has the answer. I want more of you to reach the answer. Ek baar just think, do it once in your head. What can be the options for this? How do we choose? And if you are struggling, don't worry, I will tell you exactly how to approach this kind of a problem. It's the same counting thing, it's the same addition, multiplication. Okay, 14. Okay, you're already using NCR. Well, that hasn't been covered yet, so that means you already have an idea, which is fine, which is you're using the right approach. It's correct. The issue is, if this number, for let's say it was some other problem, and in that case we had more than 4 options, would you count it for all the cases? No, right? You need something else. So let's see. Now, in his or her set of answers, so this is A, B, C, D. Let's say, if it helps you imagine, let's imagine an OMR sheet where there are options for A, B, C and D, right? Now that student can either mark this or not mark this. That means 2 options to fill this. Either they fill it or they don't fill it, they leave it blank. So 2 options to fill this blank, 2 options to fill this blank, 2 for this and 2 for this, right? So total we have 2 into 2 into 2 into 2, 16 ways of filling this, right? Either they fill this blank or they don't fill this blank, they leave it blank. Similarly for B, C, D, and this covers all of these cases. How? This means they filled A and they left B, C and D blank. So we did cover this case, right? When we counted 2 cases for this, 2 for this, 2 for this, 2 for this. So we have covered this case as well. And for this, they left A blank, filled B and C and left D blank, right? So that means there are 16 possible cases, but we're also counting this one case where this is also left blank, this is also left blank, this is also left blank and this is also left blank, which means they did not answer any question. And we have to answer a question. We have to choose at least one. So we are going to not count that one case. Out of these 16, that one case we're not going to count, but the other 15 are fine. So yes, there are 16 ways. If we could leave a question blank, if we could choose not to answer a question, then there are 16 ways of attempting or not attempting. But if we are answering a question, if we are attempting a question, then we have to choose at least one, right? We have to fill at least one of these 4 blanks. So we cannot count that option where we are leaving all of them blank, but the other 15, that is fine. So these 2 options were, we fill it or we leave it blank. We fill it or leave it blank, and so on. Okay. So once you are aware how to answer, how to solve these problems of multiple questions, multiple options, let's see. We are given 10 questions. We have to answer all of them. Okay, answer all of them. That means we cannot leave a question blank. Then the first part says all 10 questions are single correct, which means you can only pick one option, either A or B or C or D, but you can only pick one out of those 4 options. So how many ways of answering are there? 10 questions, all single correct. That means you have to pick exactly one option for all of them. So we have these 10 questions, right? For first question, we have 4 options. We can choose one out of these 4. We have to choose one out of these 4. We have to answer every question. Let's say there's no negative marking and we have to answer every question. Then it can be either A or B or C or D. So 4 ways of answering first question. Similarly, 4 ways of answering second. They are all independent of each other. No matter what you choose in first question, no matter what you choose in second question, there will still be 4 ways of answering every other question. So, and we have to answer all of them. That means we have to answer first, and we have to answer second, and we have to answer third. So it is an and situation, right? So that means we have to multiply 4 into 4 into 4 10 times. The answer is 4 raised to power 10. Or 2 raised to power 20, that is also correct. Okay, so very careful. You don't have to jump to the answer. You don't have to be very quick. Just patiently make sure that you're counting every case. For every question, there is 4 options of answering. So that means 4 into 4 into 4, 10 times. Now let's see if the questions were multiple correct, which means now there are not just 4 ways of answering. We again have 1, 2, 3 to 10. Each of them are multiple correct. No matter what option you choose in the first question, it will be an independent thing. But it's very important to understand independent. That means no matter how you answer one thing, no matter which way you choose in one event, the other event will be independent. We will not care about what option we chose. For example, here we were going from A to D, let's say via B. No matter which of these 2 we chose from A to B, we will choose out of these 3. It doesn't matter, right? As long as we reached B, we don't care how we reach. So that means they're independent. The way we are choosing to go from B to D is independent of the way we chose to go from A to B. So whenever it's independent event, that is when we can simply multiply these. So even in these questions, let's say, so what would be an example of dependent event? How would these questions be answered dependently? Let's say there were negative marking, you're sure about the first 5 questions and you think you have marked the answers according to the cutoff. You know you will pass. You don't want to risk getting negative marks, so you won't answer. But if you were not sure in the first 5, then you would attempt, maybe you would take a guess in the rest of the questions, right? So something like that would be dependent. It depends on how you answered the previous questions, how confident you were about the previous questions. That is how you will answer the rest. So that would be a dependent event. But here it's independent. We don't have negative marking. We have to answer all of the questions. We can answer in any way. So that means for these independent questions, independent events, How many ways are there to answer one question? How many ways can a student answer a multiple correct question with 4 options? 15. For second question, there are again 15, and like that for each of them. So how many total ways are going to be there? Correct. Good. So we will multiply. Because they are independent, we are going to multiply 15 into 15 into 15 10 times, which means the answer is 15 raised to power 10. So if it was single correct, we would have 4 options for answering each question independent of the others. So 4 for each, 4 raised to power 10. Here we have 15 ways of answering each question, then 15 raised to power 10. Now, solve this and give me the correct option in the chat. There are 10 lamps in a hall. Each one of them can be switched on independently. That means there are 10 switches. No matter which switch is on, we can turn on any switch on and off independently. Number of ways in which the hall can be illuminated, which means at least one lamp should be on. At least one lamp should be on, otherwise the hall will be dark. So the hall needs to be illuminated, which means at least one of them should be on. The rest can be off. Any number of lamps can be off. So if D is correct, C is not, because of this one condition. So as I mentioned, combinatorics is very important. The first step is to understand the question perfectly. Don't rush into the solution. First understand every word. They can try to trick you. Some words can be tricky. Just sit patiently and understand what the whole question means and then start answering. So here, for every lamp, lamp 1, lamp 2, lamp 10, for every one of these, we have 2 options, on or off. Independent, right? No matter what the condition, the situation, the state of this first lamp is, whether it's on or off, this one can also be on or off. Similarly, 2 for these, on or off. So total possible is 2 into 2 into 2 10 times, that is 2 raised to power 10. But if this also counts the case where all of them are off, that is also possible. That cannot be the case because hall needs to be illuminated, which means we have to subtract that one case. You remember? We just did this before. There were 2 options, but we cannot have a multiple correct question in which none of the options was answered. That is why we subtracted that one case. The rest, all of them are fine, because they all count, the rest of them count the cases where at least one of them is on. But we have to subtract 1 for the case where all of them are off. So this becomes 1024 minus 1, 1023. So option D is correct. Now, how many 4-digit odd numbers can be formed using the digits 1, 2, 3, 4, 5? Repetition is not allowed. Okay. Are you checking all the odd numbers, bache? 2 into 4 into 3 into 3. That's a weird way of counting, but sure. Let's see. So now we have to form 4-digit numbers. So just like before, we have 4 places to fill using these 5 digits. But it has to be odd. That means one's digit should be odd. As long as one's digit is odd, we don't care. The rest of the digits can be anything. Just this digit. This one's digit needs to be odd. How many odd digits do we have? 1, 3, 5. These are the odd digits that we have. So there are 3 options for filling this. Once we have filled this place, the ones place is filled with an odd digit, then it doesn't matter what we fill in the rest 3 of them. As long as there is no repetition, we will get a valid number, right? So once we have fixed one digit for this place, we have 4 digits remaining. Now this can have 4 options, then we will have 3 options for this and 2 options remaining for this, just like before. The only catch here is this place will not have 5 options, this place will only have 3 options. So the total answer becomes 2 into 3 into 4 into 3, which is 72. Right? Okay, now let's take it one step up. Now we have to form 4-digit numbers divisible by 4. What is the divisibility rule for 4? Last 2 digits, yes. The number formed by last 2 digits should be divisible by 4. Very good. So that means we have a 4-digit number. As long as this is divisible by 4, we don't care what these 2 digits are. Again, without repetition. But this should be divisible by 4. Once we fill these 2 digits, then the remaining digits can be used for this and this. Let's see what numbers can we form using these, what 2-digit numbers we can form using these 5 numbers, these 5 digits that will be divisible by 4. So first of all, now we're not going to see all the numbers possible, right? We have to be smart about it. So it has to be even. That is given. That means last digit can be 0 or 2 or 4. Now with 0, it has to be another even digit, right? It can either be 20 or 40. 10 is not divisible, 30 is not divisible. But with 2, it has to be an odd digit. That means 12 or 32. With 4, again it has to be an even digit. It can either be 04 or 24. So these are all the options that we have for 2-digit numbers that are divisible by 4. So it has to be one out of these 6. But we can't just assume any of them and the rest will be the same. For example, let's say we fill 0 and 4. If we fill 0 and 4 here, what digits do we have left for these two? 1, 2 and 3, right? 1, 2 and 3, that means this place has 3 options, this place has 2 options. But if we fill, let's say 12, then we have remaining digits 0, 3 and 4. In that case, this place only has two options, 3 or 4, and the remaining 2 digits for this. So you have to be very careful. You cannot assume that, yeah, any 6 of them and then we have 3 digits, so 3 options for here, 2 options for here, and we're done. No, because if we miss this case, then it will end up being a 3-digit number instead of a 4-digit number. So we have to be very careful, which means if 0 is there in these 2 digits, if 0 is present, then we will have 6 options. Simple, right? 6 ways if 0 is present. And if 0 is not present here, then that means 0 can be here. So in that case, there are only 4 ways if 0 is not present. So in how many of these 0 is present? 1, 2 and 3. So for these 3 cases, we will have 6, and for the other 3, 12, 32 and 24, when 0 was not included in these last 2 digits, we will have 4 ways of filling the other 2. So 4 into 3 into 4. So the final answer is 30. I hope you all are smart while calculating this. You're not doing 18 plus 12. You are taking 3 common mentally, and 6 plus 4, 10, so 30, right? Just be smart with your calculations, do it much quicker. Anyway, but I hope this part is clear to everyone. How do we make sure that we are counting all the ways correctly? Because we saw 0, we remembered that 0 cannot be in the leftmost position, so we have to be careful with that. We cannot ignore that. And that is how we calculate all of these numbers. So total 30 ways of forming a 4-digit number divisible by 4 using these 5 digits without repetition. We have taken care of all of these conditions, and these are the only numbers possible. And with this, I think you will be able to solve any kind of basic counting problem in which we have to form a number of numbers or a few options to select. So I hope you learned something new, something interesting today, something that will help you understand the following lectures. It will only get more difficult, so make sure you revise everything that we did today. Just go through everything. That should be your general rule. Whatever you cover in one class, you should revise that before coming to the next class, so that you're able to apply all of these things very easily. I don't have to re-explain how that was applied. So we will start with permutations in the next class. It will be a new topic for most of you. So just come prepared with this. If you understand this, then permutations will be very easy. Otherwise, it could be a little tricky. So we will just understand the basics of factorial, what it is, and then we'll move on to how to arrange a few digits, a few people, a few objects in a specific way. How many ways of arranging a few things are there? So I will see you in the next class. Just make sure you revise everything. I hope you all learned a bunch of new things today. Even if you did or you did not, even if you knew these basics, just make sure you revise either way. It's going to be helpful for you. And I will see you next time.